This question is called the last light bulb standing. And in this question, we have 10 independent light bulbs labeled 1 to 10, whose lifetime is modeled by the exponential distribution of 1 over 10 as the parameter for each of them. Furthermore, suppose you have an 11th light bulb whose lifetime is modeled by x follows the exponential distribution, except it's 1 over 90. Find the probability that x is greater than the sum of the rest of the 10. The answer should be in the form of this, where this is a rational number and blah, blah, blah. Find QB. Okay, so I think here is a solution that is there. I sort of just did it the same way, but I just wrote it out like this. So this is sort of what we have. We're given these conditions, right? And we're trying to find this. So I know that basically the probability that um, something of t smaller than x, because both follow the exponential distribution, we follow something like lambda t divided by lambda t plus lambda x. That's right. So I know that p of x greater than t1 would just be plugging in those things of the two parameters inside, and I would get 9 over 10. So then I just use the memoryless property of exponential distribution. Because x is exponential, I know that px greater than t1 plus t2 would just be, this is just conditional probability, right? Px greater than t1 plus t2, condition that px is greater than t1 times probability of this. Because it's memoryless, I can say that this is essentially equal to like this piece over here would be equal to this piece because it doesn't matter that x is greater than t1. As long as x is greater than t1, then I can just sort of think of it as, okay, yeah, it doesn't matter. So we have this, and then this was from before. So then I can use the exact same logic, and I would say that px greater than t1 plus t2 all the way to t10 would just be px greater than t1 all the way to px greater than t10. So then this would, each one is independent, and it's all 9 over 10, so then it's just 9 divided by 10 to the 10th power. So yeah, that would be the answer. And then you can just do what 9 over 10 times 10 because it asks for QB, right? So it would just be 9. I was honestly during the question kind of confused. Okay, so this seems like using the memoryless property seems so similar to if I was to get the maximum. So what would it actually be if I was to find the maximum instead, right? So if I was to find the maximum, it means that each of the x would be greater than the t1, t2, all the way to t10. So by law of total probability, I can condition it on x equals x. So if I was to x equals x at that point, it would have been something like this, where they're independent, right? Because all the t1s have to be smaller than x, so each of them has to be smaller than x. So there would be something like this, and I can just multiply it together because they're independent. So then I know that the probability of this happening is 1 minus e negative lambda x. And then each one is that, so I have 10 to the 10th. And now what I have is, okay, now I have to bring it back, right? Now I have to condition it on x. So I just have to times the PDF of x. So this is the PDF of x, times that together. And I know that I can use binomial theorem to expand out this part, right? If I expand it out, I would get something of this form. And then what I can do is I can just use the fact that the integral of e to the negative ax would just be 1 over a. And then I just extract out the constants in front that have nothing to do with the things. So hence I would get this would be my answer for maximum. This is not part of the question, but it was just kind of for me to kind of clarify the difference between finding the sequential sum that I use the memoryless property versus if I was just to find the maximum of the things and then break it down into each of them is bigger than that. And yeah, this is the solution. Yeah, basically, this is just more written out of why the memoryless property works and how we plug it into each of them, right? And enough here.